When early philosophers studied the world around them, they theorized that everything around them was made up of one of four different elements: air, earth, fire, and water, and that everything was made of either one or a combination of these four elements. The problem was that they didn't have hard experimental evidence to back up these claims. About this time, about 400 BC, a philosopher by the name of Democritus came up with the idea that everything in the world around him was made up of two things: empty space and tiny little particles, which he referred to as atoms. And so this was really the birth of what is referred to as atomic theory, the theory that all matter is made up of particles called atoms. Once again, the drawback here was that Democritus did not have experimental evidence to be able to back up his claim. Towards the 1700s, almost 2,000 years after Democritus had conjectured that matter was made up of atoms, scientists started to pick up on this theory again. One of the scientists to do so was Antoine Lavoisier in the late 1700s. During his experiments, he determined that when a reaction occurred, the mass of the reactants that he began with would equal the mass of the products that were produced after the reaction, indicating that nothing was totally eliminated. Even if an experiment looked like matter had disappeared, it truly hadn't. It was just in a different form, maybe that couldn't be seen, but it was still there as determined by its mass. And this became known as the law of conservation of matter, or the law of conservation of mass. Matter cannot be created or destroyed, only changed in its form. Following Lavoisier's work, Joseph Proust determined that for a particular compound, the compound had a fixed ratio, a fixed composition, and that the elements that made up these compounds were always found in this same ratio. For instance, water is always 2 parts hydrogen to 1 part oxygen. Sodium chloride is always 1 part sodium to 1 part chlorine. And so this became known as the law of definite proportions. In the early 1800s, a scientist by the name of John Dalton, who was also looking into this idea of the atomic theory, had studied the work of Lavoisier and of Proust and others, and he took their findings and compiled them together and linked them in, tied them all together with this idea of the atomic theory. And so this became known as Dalton's atomic theory. First premise of Dalton's atomic theory was that all matter is made of atoms, just like Democritus had postulated back in the 400 BC. The second tenet of his theory was that atoms are indivisible. They are the smallest form of matter that you could possibly have. And finally, that atoms of one element are exactly alike, and atoms of different elements are different from one another. Dalton's theory was pretty much correct, but as with all scientific theories, with additional experimental evidence, even theories can be disproven. And so in the late 1800s, early 1900s, Dalton's theory was modified slightly. The first part, that all matter is made up of tiny particles called atoms, that was fine. The second part, where he said that atoms were indivisible, this was found to be false. It was discovered in the late 1800s, early 1900s, that atoms were in fact made of smaller particles, namely protons, neutrons, and electrons. The third tenet of his theory was that atoms of the same element are all exactly alike, and atoms of different elements are different from one another. And while that second part does indeed hold true, the first part, atoms of the same element being exactly alike, was also found to be incorrect. Atoms of the same element will all behave similarly chemically and physically in terms of their properties, but it is possible to have atoms of the same element that vary slightly in their masses. And so again, it was the discovery of these subatomic particles in the early 1900s that helped to explain this discrepancy. As far as the early research on atomic particles, the first of these particles to be discovered was the electron. J.J. Thomson and his team of physicists in the late 1800s used a cathode ray tube to identify that cathode rays, which had been discovered by Crook, these cathode rays were actually streams of particles which were found to be electrons, and through manipulating the electrical and magnetic charges and magnetic fields that these cathode rays were exposed to, was able to determine the size of the charge on an electron. With the cathode ray tube, the positive electrode is called the anode, the negative electrode is called the cathode, and because these rays originated from the cathode and were attracted towards the anode, hence the name cathode ray tube. Robert Millikan, about 10-15 years later, around 1910, used his oil drop experiment to determine the mass of an electron using the charge to mass ratio that had been determined by Thomson with the cathode ray tube, and also his own observations as to the charge on a single electron. The second particle to be discovered was in the mid-1910s to early 1920s. About 1918, Ernest Rutherford carried out his famous gold foil experiment. And this experiment had two main conclusions. One, that an atom was mostly empty space, and secondly, that there existed a very small, dense, positively charged core at the center of the atom. And this is where the protons were located. It wasn't until about 10 to 12 years later, following the discovery of the electron and the proton, that a third particle was discovered. Up until this point, when James Chadwick discovered the neutron in the early 1930s, experimental evidence had shown that atoms of the same element didn't all have the same exact mass, and it had been determined that the proton had a mass almost 2,000 times heavier than an electron. So it wasn't possible for electrons to account for this discrepancy, yet if you changed the number of protons, you changed what the element was. And so this left a bit of a mystery. Well, Chadwick discovered that there was a third particle that was neutral in charge, and it had a mass almost exactly that of a proton. And in fact, Rutherford had theorized that if you took an electron and a proton and put them together, that they would create this neutral particle, which became known as the neutron.